I welcome all of you on the platform of Yourpedia Education, and you are watching now a series we have started on actual real asked questions in BARC interviews. You know, it is an interesting series. Why? Because BARC is supposed to be mother of all the interviews. You know, BARC interviews is supposed to be mother of all interviews because it is supposed to be very grueling and very in-depth interview session, long duration session, approximately 1 hour, and they tend to ask you questions which check your thinking, and they keep on taking you deep into the concept. They ask you your favorite subjects, and from there then they start asking you questions. First the questions asked are very simple, and then they keep on taking you down into the concept. They check your analytical skill, convergent thinking, your mathematical skills, and your interpretation power to put the things together. Now in this series we will always come out with one question or one particular. They don't ask many questions. What comes to the mind is, like, if it is for 1 hour session, maybe they will ask you 20-30 questions. You will be surprised to know sometime in 1 hour they ask only 2 questions, but in that particular they keep on going in the deep of that particular subject. So today's lecture, this particular video is related to one such question in BARC interview asked to one of the students who gave us feedback, and I will be presenting this entire session with you in question answer types. So what question they asked, and then what should have been the answer. So what question they asked in the interview and how you could have approached for that, and how the questions are actually framed. So this question is related to the subject thermodynamics. In BARC they will ask you to name some your favorite subjects. Normally they ask 5 subjects. You have to choose those subjects carefully. Out of these 5 subjects, your core subject should be there. Does that mean they ask you question only from these 5 subjects? Answer is no. If you have missed some important subject for which the mentor is sitting there, the interviewer is of particular field, and you have not mentioned his field, he may ask you question from there. For example, if you have not mentioned production engineering, you have said thermodynamics, fluid mechanics, heat transfer, strength of material, and IC engine, let us say. You did not mention production, but the mentor is of production, he can ask you question from production. So now it is your responsibility to mention the subjects such that your entire engineering is covered and main core branches of your engineering are covered. You have to mention something like that. Now I take this example of thermodynamics today. So in BARC, interviewer must have asked the candidate about his favorite subjects, and he must have mentioned thermodynamics. And as you know, in the thermodynamics, how you start is, what is thermodynamic properties. So the first question was, what do you understand by thermodynamic property? Very simple. And don't answer the bookish knowledge. You answer what you understand. They appreciate if you give your answer from the understanding level, not bookish rote memorized answer. Don't give that. Then the boy must have answered, sir, thermodynamic property defines the thermodynamic system. So it is the property of the system in terms of which we can define the system. And there are some examples of that, sir. Like temperature, I can define a system in terms of temperature. You can always give example to make them understand the concept. They are beyond language, even if your communication is not very good, but you are making them understand concept, it is always good. So then you explain, sir, like temperature is a thermodynamic property, pressure is a thermodynamic property. So if I am to define this room, I will say the size of this room is this much, length is this width is this, height is this, volume is this, temperature is this, pressure is this. So thermodynamic property is something in terms of which you can define your system, and you can measure thermodynamic property at particular state, and there are tools and devices to measure the thermodynamic properties. Like we have scale to measure length, we have thermometer to measure temperature, we have manometers to measure the pressure. So we have devices to measure the thermodynamic properties, in terms of which I can define my system at a state. That state should be equilibrium state. Done. Then next question is, what are the properties of thermodynamic properties? What are the properties? And you know, in that, what are the properties of thermodynamic properties? So, the answer to first question would have been, define the state of system. So, thermodynamic property is something in terms of which you can define the state of your system. What are the properties of thermodynamic properties? All of you know, they are the point function. They are the point function, not the path function. This comes to your mind. They are the point function. I mean, you can measure the properties at a particular point. You have to measure these, measure at a state in equilibrium. Remember that unless until the equilibrium is hit, you cannot measure a thermodynamic property. So, to measure a thermodynamic property, your system should be in the state of equilibrium, and then you have different kind of equilibrium systems, you know, thermodynamic, thermal equilibrium, mechanical equilibrium, chemical equilibrium. You have a couple of types of equilibrium. So, unless until equilibrium is attained, you cannot measure the state of a system. So, they can be measured at a state. They are exact differential. These are exact differentials. Now, what is the meaning of these are exact differential? That you can explain them. That simply means, sir, if x is a thermodynamic property and I am taking the integration of dx, that simply means x2 minus x1. If I am taking integration from 1 to 2, that is how you explain. So, the exact differential means when I am integrating the dx, if x is a property, I get x2 minus x1. So far, so good, it is okay, you can answer this. Can you give the example of thermodynamic property? Yes, why not? Sir, temperature I can measure at a point, pressure I can measure at a point, volume I can measure at a point. So, most commonly used thermodynamic properties are these. Then sir, we can say enthalpy, we can say internal energy, we can say entropy, and we can say even total energy of the system. So, these are also thermodynamic properties, and all these Gibbs function, Helmholtz function, these are all your thermodynamic properties. You can measure these properties at particular state. And then in terms of these properties, you have property diagrams, PV diagram and TS diagram, you have PV diagram, you have TS diagram, you have Mollier diagram, HS diagram. So, the diagrams are drawn in terms of thermodynamic properties, temperature, pressure, volume, and we have thermodynamic tools and devices to measure thermodynamic properties. Can you tell me which are the thermodynamic properties? Now, you see, he will keep on increasing. As of now, he is asking you, you are sitting and he is asking you question. Now, he will keep on increasing the difficulty level, and the next question is popping up from what answer you are giving. I really don't know what answer student must have given, but next question keep on popping from the answer which you give. Now, the next question comes is, which thermodynamic property are there in first law for a process? You know, you can write first law of thermodynamics for closed system, for open system. You can write first law for a process, you can write it for the cycle. You need to be very specific. What are you writing first law for? Process or cycle? Closed system or open system? You need to be clear in that. So, if you are writing first law for a closed system or a process, normally this is what you write. So, dq is equal to delta u plus p dv. Okay, done. So, what are the properties in first law for a thermodynamic process? Okay, sir. So, this is the property. This is the property, whereas this is a path function, not a property. This is PdV work, path function, not a property. So, only change in internal energy is a property. Why? Because if I write now 1 to 2, I can write it as u2 minus u1, and at this point he said you go to the board and write this equation, and then you wrote this equation. So, you must have heard that in BARC interview they will ask you to go on the board and explain it everything on the board, कि बोर्ड पे जाओ और वहाँ पे लिखो, और बहुत कूल चलता है, मतलब बहुत कामनेस होती है, बहुत ज़्यादा टाइम मिलता है आपको सोचने का, अपना आंसर करने का. दे गिव यू सफिशिएंट टाइम बिकॉज यू आर देयर टू सेलेक्ट द साइंटिस्ट, सो वो आपको काफ़ी टाइम देते हैं. एंड द स्टूडेंट्स हु आर टोटली काम एंड कॉन्फिडेंट एंड कंपोज्ड, नॉट नर्वस, and they are thinking, they are struggling to find the answer, they are trying their level best to find the answer, they are normally selected. Now this is what happened. Now let's go to the next question. And now he says, can't you use specific enthalpy in the first law? This is what you have written, dq is equal to delta u plus pdv. This is what you have written as first law for a process in a closed system. And now he says, can't you write enthalpy in this, specific enthalpy? What comes to the mind is, he is thinking now, how can I write first law enthalpy, because he is asking you, this is for a closed system or open system. I have written is for closed system, okay. What kind of, how do you know this is closed system? Because this is a PDV work. I am saying this is a displacement work. I am saying this is now displacement work, okay, and internal energy. So displacement work, internal energy tells me that I have written it for closed system, okay, done. But specific enthalpy is something which we calculate for the flow system. Specific enthalpy is something which we calculate for flow system, that means open system. That is what comes to our mind. I am not saying it is correct, but I am saying that comes to the mind. The moment student was thinking, the next question popped up. The question is, can you give the relation between specific enthalpy and specific internal energy? You understand, specific internal energy, specific enthalpy means enthalpy per unit mass, that much you know. Enthalpy is equal to internal energy plus PV. This PV is called flow work. This is called flow work. When I take specific enthalpy, all the terms will come per unit mass. Specific enthalpy is equal to specific internal energy plus specific flow work. Small u, small h, PV, and this one is specific flow work. Then he asks you, is there any relation between specific enthalpy and specific internal energy? Yes sir, we have, and that relation is h is equal to u plus PV. Okay, done. Then next question pops up. What do you understand by specific flow work? Okay sir, h is equal to u plus PV. This is specific flow work. Now what happens is normally student, whenever question is asked, student get confused between steady flow work, specific flow energy and specific work. These three are different terms altogether. Student get confused between specific flow work, which is this, specific flow energy, a term which comes in steady flow energy equation, and steady flow work. Steady flow work is different from your specific flow work. Steady flow work comes in the equation of first law of thermodynamics for flow system. So steady flow work is a different thing from specific flow work. Understand that. Now this was specific flow work. He asked you about specific flow work. What is specific flow work? And you are explaining what do you mean by specific flow work from this equation. He is not interested in this equation. वो होता क्या है? Can you explain through example what is specific flow energy? Specific flow work, sorry. Now this is the minimum energy required for the fluid to flow. Means I drop water on my hand, let us say. I drop a water on my hand. Now this is not flowing. Tilt your hand at one particular point. You have done that in friction also. At one particular point of inclination, the fluid will start flowing by overcoming the friction. In case of fluid is viscosity. So at one particular point, the inclination of gravity will give you energy for the fluid to flow. That minimum energy required for fluid to flow by overcoming the internal friction, something like viscous friction, is called steady flow work. So if I write minimum energy required to overcome friction and start the flow. So that minimum energy required for fluid to flow is called specific flow work. If you give this answer, these both things, he may get satisfied. Now comes next question. Is it a property? Now you are confused. H is a property, internal energy is a property. What about specific flow energy? You know, H is a point function, U is also point function, H minus U is also point function. So left hand side is a point function, this is a point function. What about specific flow energy? What do you understand by specific flow energy? Is specific flow work, is this property now? That is the next question, and majority students will get confused here. So you will start thinking, and you know how the approach should be. The moment this question is asked to you, don't be in hurry, don't jump to the answer. This is not public sector interview. This is not the interview where you have to give questions, answers, question. It is not a rapid fire type of question answer going on. It is not a campus placement interview. It is a Bhabha Atomic Research Center interview. That means you need to be patient, you need to think what question is asked and then think and then answer. You cannot afford to give wrong answer. At least approach should not be wrong. Yes sir, I think H is a property which depends on the point state. U is a property, again that depends upon the points. U is also point function. So difference of two point functions is also should also be point function. So in my opinion, yes sir, specific flow work is also a property. Yes, it is property. Yes sir, specific flow work is a property. Can you prove it? Can you prove that it is a property? Maybe next question he asks you. What do you understand by, in the beginning you said it is exact differential. Now can you prove it that way? Ideal gas equation, if I give you help of ideal gas equation. Sir, in the ideal gas equation, PV is equal to RT. Maybe you have done this. PV is equal to MRT, but P into small v is equal to RT. Now, PV exact differential should be P2 V2 minus P1 V1. If we are in position to prove that, we can say it is a property, right or not? Exact differential. Let's say I replace PV with RT. D of RT 1 to 2. R is common, R is constant, I take it outside. I can write it RT2 minus RT1. That exactly is what I've got. So as you can see, R into T2 minus T1 is P2 V2. So I can prove it that yes, it is an exact differential and hence it is a property. So he is asking you these questions. Now the student who is not very clear will falter at the stage of, is specific flow work a property or not, and what do you mean by that? Then he will ask you dH minus du. dH minus du. Can you say this is a property? Yes, this is a property because dH 1 to 2 minus du 1 to 2 is H2 minus H1 minus U2 minus U1. So this comes out to be H2 minus U2 minus H1 minus U1. And what is H minus U? That is PV. Eventually this is nothing but P2 V2 minus P1 V1. Yes, that also proves. Now they are the linked question, you know, he is asking you all these questions, they are the linked question. Many students ask that BARC interview keeps on going for an hour and 25 minutes, क्या चल रहा है उसके अंदर ये आपको एक एक क्वेश्चन वो देता जाएगा एंड आपको टाइम देगा सोचने का, you will keep on thinking and you will keep on approaching further, and then he asks you to write two things on the board, PDV plus VDP and PDV minus VDP, and prove which one of these two is the property. Let us say now he gives you this, he gives you dz as PDV plus VDP. In this case also dz is equal to PDV minus VDP, and ask you to prove which one is exact differential. Now understand, if z is a function of x and y, exact differential is curly x, curly z over curly x dx plus curly x over curly y dy. You know that. I can write it as mdx plus ndy. I can write it like that. This is mathematics. You have done that. If z is a function of x and y, then dz can be written like this. If curly m over curly y is curly n over curly x, then z is exact differential. This is what mathematics may you have done, right or not? You have done that in mathematics. Now come back to the question he has given you. Let us say this is dz. Don't you think as is a function of p and v? It is looking like it is a function of pv, because one is p, another is v. Now if I open it like this, you see in this particular case, let us say x is p and y is v, let us say. I compare this dx, so this dz is equal to dv curly z over curly v plus curly z over curly p dp. Now I can compare these two. Now what is curly z over curly v? If you see, this is coming out to be p. And what is curly z? Or I can write it as m dv plus n dp. What is m? Curly z over curly v. So what is curly m over curly p? If you see, m is nothing but p. And what is curly m over curly p? If you compare these two, p is equal to m. What is curly m over curly p? That is equal to 1. What is n? Curly z what is n? N is curly z over curly p, which is further equal to v if you compare this. And what is curly n over curly v now, which is 1. So this is satisfied, and hence PDV plus VDP is an exact differential for us. That is an exact differential. Otherwise also there is an indirect way. There is an indirect way. PDV plus VDP, is it an exact differential or not? There is a direct way. H is equal to U plus PV. Okay, DH is equal to DU plus PDV plus VDP. So what is PDV plus VDP? It is equal to DH, right? This is what you get. So if you integrate it, this is how you can directly get it. Now let's go back to this. Now this is mdx plus ndy and dy. What is M? P. What is N? Minus V. Okay. When you do curly M over curly Y, Y is P, it comes out to be 1. When you do curly N over curly X, it comes out to be minus 1. So this is not coming, curly M over curly Y is not coming curly N over curly X, hence it is not a property. PDV minus VDP is not coming out to be an exact differential. Let's go this side. If I integrate both sides, I get this as H2 minus H1 minus U2 minus U1. Hence it is property. Hence it is property. Let me write now dq is equal to dh minus vdp and dq is equal to du plus pdv. Plus pdv. You know, when he asks you to write first law in terms of enthalpy, this is how you should write the equation. Can you tell how do you get pdv plus vdp? Equation number 1, equation number 2. 2 minus 1. Do 2 minus 1. Left hand side gets cancelled out. pdv plus vdp. pdv plus vdp is equal to dh minus du. This is what you get. If you do 2 minus 1, this is what you get. Now you integrate both sides. Now you integrate both sides. You get exact differential. You are getting the exact differential, right or not? Can you do the same thing? Can you get now this term for me, pdv minus vdp? Can you get this term for me from here? pdv minus vdp, just add it up. If you add 1 plus 2, what do you get? pdv minus vdp is equal to, I am to add it up, 2 dq, and then there are some more terms. Right side it goes pdv minus vdp, it goes du minus dh, something like that. I am not interested in these terms. So the moment I do pdv minus vdp, 2 times this plus du minus dh. Now this term is a path function. As you know, dq is a path function, and hence pdv minus vdp is not a property. Now this entire story takes time. This entire question, how it unfolded, how they asked you to find the answer to this. What do you mean by exact differential? Can you write pdv plus vdp? Can you prove that it is exact differential? Can you write first law of thermodynamics in terms of enthalpy? Can you write first law of thermodynamics in terms of internal energy? From these two equations, can you prove that pdv plus vdp is an exact differential, is a property? What happens when I add two thermodynamic properties? Now next question you can give you this, dh minus du, dh plus du. Are these thermodynamic properties? Answer is yes, both are thermodynamic properties. Why? Because if you do this 1 to 2, or if you do this 1 to 2, you get properties H2 minus H1 minus U2 minus U1. In this case also H2 minus H1 plus U2 minus. So both are properties. Both are thermodynamic properties. Just revise 1 or 2 or 3 subjects in totality and BARC is yours. All you need is, you need to have in-depth knowledge, and if you acquire that, surely you will convert that into selection. So The preparation of interview in BARC is entirely different from others. Let's start preparing and let's convert our call into selection. It requires patience, effort is required, but we can do that. Hope you understood this entire story. Now I will give you this entire document. Download this document from Yourpedia platform and listen to this entire thing and attend and keeps watching all our series. Our mentors will come out with a lot of many series related to BARC hardcore question, the mother of all the interviews in India. Thank you.